Stage is yours.
Okay, thank you. Uh, like I did not write a slide about me, introduction about me, so I will just do it on the first slide. My name is Aqib, and I'm working as a system architect at Elektrobit, automotive, and I'm here with Isaac, also my colleague here. And my topic is more like I would like to start with one picture, which is like I know Halloween is gone, me and Isaac was one at, I say, functional summit, function safety summit, and there were people like talking about it, like hypervisors, but like somebody named it and everybody did not name it. It's so bad. So there were some OEMs, like they were just shouting, "Don't name it." And we were like worried, and we were like, "Why? Well, why are you worried like so much?" And so this is like was my motivation to just create awareness. What's the issue? First to understand and also explain the realities of what is actually is and as compared to what is there are misconceptions. And also like if they are so scary, so why do we use it for safety domain as well? So first, like just not even in safety domains, people are scared. And now if they are scary, why to use it in safety application? But the point is that what exactly like in automotive, like we look for, what are our wish lists and what we want to do it. And like we want an operating system which is safe and also secure, but free of security. If there is no vendor locking, and we want it to be like it has sports standard interfaces so that if you use it in one project, you could use it in other projects. It's not a one-time use, it's scalable. And it should be widely used because if a lot of companies are using it, then you need a lot of wide need of developers to work on it. And OEMs should be using it and also the hardware vendors so that if they introduce a new hardware, there is a BSP support. And you also want like a regular updates to have more security. And you don't want to, even if you are updates, you want to avoid again and again safety and security assessment. So this is like our wish list, which we want, like this is the ideal for any operating system, which we can fulfill it. And now I come back, like when we were sitting at that place or at that summit, I asked like, what are your biggest fears? And they were not a lot. The first one, somebody said they are slow. And I said, okay. And one other perspective was like most of the hypervisor which are used are closed source. Like for example, Samsung has its own, Nvidia has its own. Then you have like others, proprietary ones, Cisco, UNX, all are closed source, and we don't know what is in like they are not open but for public. Then one other person said it like, yeah, but if you even if you do have to do small surveys, you always need an operating system to run on top of hypervisor. You need even RTOS, even if for small things. I had like from past projects, they said we want to do small surveys, we had to run a RTOS even to do small that application. So that was another concern. And the one interesting comment was the person said, I used in Hypervisor in my project around 20 years ago. It was a very bad experience. So it was an experience based. And now I don't even like the name. So they said it should be some other name of this. So because of the past experience, because 20 years ago they worked in the projects and it was not a good experience. So like I just said, okay, let's do a reality check of if they are slow. Yes, it could be slow 20 years ago, but with the new hardware advancement last couple of years, especially start of 2010, there is like and also ARMv8 coming. There is a hardware assisted virtualization. Its software virtualization is almost nothing, none. Like you have now separate execution layer, you have like separate system registers, you have MMU capable of virtualization, you have virtualized interrupt controller, even with V4, don't even need to have interrupts in your hypervisor. You can directly forward to your VM. Now, even you have hardware-assisted devices virtualization supported like GPU here. There is a GPUs, Mali GPUs, for example, which can support virtualization in the devices. So you don't need to have trap it, even the devices when you are sharing it. So if you use the correct hardware, which mostly are using it, but they're not using the full capability. So I think the argument they are slow is just like you have not configured correctly is the reason. So you have to just design your system properly, and they are not slow. Then the other thing, which is correct, like in some perspective, that they're most of the hypervisor which are in industry are like some are not open source, closed source. I really agree. Like for example, the Qualcomm one, or the NVIDIA, or the FICO Cisco one, or you go look QNX. So they are, but this is not the full reality. There are some hypervisor. I know the Zen hypervisor, which is used in not in automotive, but also in server market, is open source. And the Linux Foundation is working quite actively to what?
It's used in automotive.
Yeah, but in the Zen, it was started from the servers. Yeah, Oracle was the one. Like now, Zen Foundation is like the Linux Foundation is working to safety certified it. There is a process is going on, although funded by like some hardware companies mostly. So it's used, and it's getting safety certified. So it's not just the closed source are safety certified. And then there is like also L4 based hypervisor, which is already safety certified 3 years ago. And also it has like a German like Geheim approval for security. So there are some available hypervisor which are in open source, which are like safe and secure.
You got it.
And then the next one, like you always need an operating system.
But they are not safe. I mean, they are available, but they are not safe and secure. You say available, safe, and secure.
But
Not safe.
but why do you say it's not safe to use?
Because there is no safety certification for them.
No, but I'm just saying that we have like a safety certificate suit for L4 hypervisor since 2 years ago.
Yeah,
You
but
have
this is not
you
open
forward.
source. This is
Yes,
open
and it's
source.
open source. The only thing which we are hiding is like a safety package. So you can use it, you can start developing it, but of course, if you want to go to production, you have to buy the safety. So what is the safety documents, test setups, and all these things
But
are.
that's the actual work, I guess. That's what he's referring to.
Yeah, but it's not like you have to, when you want to buy the safety, you cannot start developing it. You cannot use it. It's not even licensing like hidden that you cannot use it.
So most important thing for use something safely is a safety manual,
Yes.
which tells you what to do, what to be allowed and what not. And this is naturally not open because a lot of
Yeah, it will be same with the Zen. When I'm talking to Linux Foundation, like they say Zen is we will certify it, but of course somebody has to pay for this. Like this, so safety manual will be only get who will this it, but it
Yeah.
does not stop you to develop your system at the beginning. And then of course, when you want to go to production, you want to like do some contract to get the safety documentation.
But if you have developed your system without a safety manual, it means that per se your system is not safe. So that means that maybe you will come up with a lot of changes because whatever you have implemented in your system once it was free, it was not considered as a safe application in the safety manual.
Yes.
So that any developer that will start cannot start without safety manual if you are talking about safety applications.
Yes, right. If you are developing safety application, you should start always from the beginning. If you are doing like a normal development, no, it's not like you can do your QM development whatever you want, and when you want to use safety development, you should contact the person who has all done the safety certification. But the other thing is that they are source code is available to look into it, what you are doing, what you are developing. You are not dependent on something behind the closed doors where you even if there are I know some hypervisor which you don't get, you can just get the binaries.
Hypervisors, if you buy it, you will get a source code.
And that is the second point, that if you will change any tiny thing in this source code, then it automatically means that you lost the certification. That basically, like, there is no more any additional benefit of having the source code in this case. And
Yeah,
no
but
additional
no.
free.
I think
There is a difference because
like
because-
what is benefit from your point of view?
I will tell you, like for example, the Zen hypervisor, the community, how it is doing it, like it's not like if they certify it once time and then if anything open, like because it's open, anybody can create a pull request, and after that it has to be recertified. it's not the approach that Zen is using it. So you don't have to recertify it again and again each time there is a change. So let's see how it goes. The Zen project is how it is doing it. There is a set of checks, safety checkers, which have to be each change which is going there, have to fulfill it. And if it fulfills and complies with those, then they don't have to recertify the safety certification of the Zen hypervisor. So this is the approach which Zen is taking it. So if you are doing a change, please create a pull request, go through all the safety checkers. If it is accepted, merge the process and everything which they are doing it does not require you to do again a safety certification.
And this is actually something you will find in certification authority reports, even some which are freely available, where it says a code change does not require a recertification in case you are following rules. The best case of it, where you can directly read it if you don't trust, there is the assessment report from the Red Hat drivers. So you can go from the ELISA webpage and find the assessment report, where also some statements are made, how updates of the software stack are treated. And I think so you need to read it on your own. My brain says, as long as you stick to the Renaissance S4 hardware stack, you don't need to, and you can have software updates in the stack when you're in your process environment where it has been assessed, because you take all the rigor and things so that if you do some changes, this will still comply to all what we have said. We wouldn't come to a different result, something like this. So you can check for it, drivers, Exceeder, assessment report, you search for it, you should find these kind of things.
And exactly this is the approach which Zen is also following.
Yeah. So when we do market qualification for tools and libraries, this is like the prerequisite for a certification. We have 3 different variants. So the first variant is it's pre-qualified. So we just say this in this version, in this environment, on this hardware, you can just use it. It's of course the cheapest version. The second version is, like we say, the customer specific one. So you tell us, oh, I have this environment, I want to use this version. Then we build up this version, this exact environment. We run the test for you, we ship it back to you, the second model. And the third one is what we call the continuous qualification, or the flat rate, meaning we set up a process that you can develop things and rerun test cases, and then always have your certification in a sense, or qualification, actualized.
Yeah, for tools, it is clear. For the running software, then it should contain some subset of evidence in order to prove that process was followed and so on. So it is.
And I think you made a fair point when you said when you modify the source code, then you lose certification. That's right. When you are the consumer of this and you modify the sources, and I guess this was one point which you want to bring up, like, where is my benefit in seeing the source code when I cannot modify the source code, right? So this is how I understood what you were saying to a certain extent. There are 2 things to consider there. We were in the project arguing hard. It was on a proprietary driver, and we had expertise in this domain. So we struggled with the supplier for 2 years roughly to get access to the source code. And we actually then half a year later found a bug while debugging in the source code. So we did not modify the things, but we could report back. It was not safety critical. There's just like a proprietary software stack, which is well used, but this helps us. So we get a better understanding and we have the chance to understand things. And to me, there is a safety manual, but often the safety manual thing comes also in just for the case to, like, I don't have full access. I cannot understand everything. Let's say if I have 1,000 lines of code where I get a full understanding, this would be a safety element. And I have it as an open source project. I may have the chance to understand it, to operate it safely, even without a safety manual. So the safety manual may not add additional value. So I can gain understanding, I can use it, I can see that it's configured properly, even without the safety manual. On the other side, when I have safety manual, it does not guarantee that my overall system will be safe if I'm not, even if I follow all parts of safety manual, it can still result in an unsafe product. Right? It's also,
yes, for sure.
Yeah.
If like as a combination of those 2 factors of having a source code and having the opportunity to analyze it. And in addition, having the safety manual so that safety claims from the suppliers are fulfilled, then it is a nice and very safe option that helps. If any of those parts are missing, I have some doubts that it can be safe in general.
Yeah. Also, you had a very good point about having evidence, like if you change a source code by yourself, what is the evidence? So for example, I can give you like on Zen, if you create a pull request now, they have defined like even there is a set of tests which needs to be run, and also like static code analysis is run on like for developers which are allowed to do like the changes. So it's not like when you do a change, there is a set of evidence created for each book, but it could be, I fully agree, it could not be happen a very big, like there are like millions of developers working on it. If there is like a hypervisor code is not very big, and the changes done into it is not very big. So there is, if there is a change, there is evidence generated for each change, that this change was introduced with this change of test was run, and this there was this static code analysis was done. So there is a set of things which has to be generated for each source code. Of course, if you are doing a change and not like following this process, then yes, it's not safe, but like you can define a process, okay, if anything has to go through this process, then it should generate all the evidence.
So it has to be
Mhm,
clear
sure.
when you qualification and certification, there are two kinds of things. You can qualify products in the sense that you get a binary and you can have it, and then you can compare it, whether it was in the machine, was your binary, your product. So this is product certification and qualification. And the other thing is process certification. If I follow something, a process, then it will be safe. And that's sometimes it's a bit mixed, and we should not mix it in our mind. So this is important to separate.
Before we continue, there's
Perhaps-
someone from
perhaps-
the workshop that is trying to speak up 2 times, so I guess it was.
Yeah, but perhaps, yeah, perhaps for avionics, normally, the question is why you want to use a hypervisor. Normally for us, it is, let's say, to have some segregation. And there is also the possibility, as you can read here, the segregation that you can segregate between virtual machines. So we also have to fulfill some security issues now, and mainly if you go to higher secret levels, not restricted or not a secret, it is needed to have the source code to be able to, all the source code of the hypervisor will be, let's say, inspected by the authorities. So I think in this area, and it's also good that you have a hypervisor solution which has very reduced code base. So it's very simple solutions here are, let's say, are much more beneficial. For safety, this also helps you. But in airborne, you have the problem with the worst case execution time to be shown. And so on multi-core and let's say hypervisor, sometimes this is very difficult to show the worst case execution times really in a good way and to show it. But in principle, we have also here how you see some applications directly running on the hypervisor. Because this could be, let's say, a security gateway function. So you have 2 virtual machines, Linux. You have unsafe code here inside, but you have segregated these domains by the hypervisor, and then you have a very small application which is a gateway to ensure that only the proper information can pass. So I think this is a very, very interesting technology for even for safety and security.
Yeah, thanks for that. Yes, that's a very good point. And this was also about my slide that you can always run also, not on all. Okay, so there are some hypervisors in the market which does not support kernel threading, like for example, and does not allow to run this small application which you could use for safety or security, but mostly have like some small time runtime environment where you could run it like you're this small secure or like for safety purpose, for any purpose, you could run it directly on hypervisor without any operating system as well. So there is also this possibility which gives you benefits from this. Any further comments before I move to the next slide?
Just the only comment, you've roughly 9 minutes just for your.
Okay, so I have to be quick. So like, sorry, as I'm working in automotive domain, so I just put a reality check. Okay, so if hypervisors are very good, then what is that? So this is a Business Insider survey for automotive Asia Pacific, so not a worldwide. use it. And it says around 315 million in 2024 hypervisor market size, and it is going to increase by projected increase around 4,000 million by 2038. So like almost getting like 10 times more from just 8 years. So like it's going to be used a lot in automotive, but that's a projection by Business Insider. This is Asia Pacific survey for automotive hypervisor market. And if they are used already, where are they used? Mainly they are used like you have like a modern ECU or HPC, they want to have a consolidated one ECU, you are running Android, and you want to have another operating system in the parallel. So it's are used. And also I have seen in a lot of cars running with the in gateway controller hypervisors, where you have like 3 different operating systems which have 3 different roles, and you want to have isolation between them, and they have a dedicated core. So it's a small with 8 cores and 3 cores assigned to each operating systems, and you want to have isolations because sometimes these in the cars, even the operating systems are coming from a different vendor. So like one operating system from one different company, from one different one, and they want to have like hypervisor layer to just have ease of integration. And the question comes, why don't they just put like, if they are a dedicated course, why don't they just put a separate ECUs instead of having like cost? Like in automotive, you want to save the cost. You want to have one ECU consolidated with Android, Linux, or any other operating system, RTOS on one place. And also, of course, that it gives you benefits also about the security, that you have different operating system running and more isolated and segregated. And we saw, as we saw in the previous slide, that its projection, it says that it's going to increase more. And now that here's a huge demand in ADAS domain, that you want to have like Android running, like for example, the big example is that you want to have an instrument cluster running hosted by Android, and then you have like a teletails, which is on top, and it has like a safety requirement. And you want Android not to drive that dedicated. So you want another operating system which is safe and you can trust, and that is the one which is overlaying the teletails on top of and instrument clusters. So you want to have 2 different operating systems running in parallel, and this is the one thing which is like not SIL2, maybe there is a SIL2 requirement, and this is in automotive, there is a high demand of this kind of use case. Now we have seen like it's already used hypervisor, and it's going to be used more like in automotive. Why not just like extra use it for some other purpose also? Like it could be like also use it for safety purpose. Like why not we use it? That was the main idea, and it is not as okay. So the main idea is that to just add another thing, like which could be like explained by here. If I could have a pointer, let me see if I can use the pointer. Yes. So like normally, like we have like a hypervisor provide separation between different VMs. So you have like a isolation between different VMs, and you have any operating system, let's say any Linux, which provides you separations between different processes. You are running different processes. So what we say, like, we can run another safety monitor, which could be just a hosted application on the hypervisor, which could provide another isolation between your kernel and your user space. And then if you have a SIL requirement on your user space, then you don't have to be much worried. Okay, it does not mean you don't have to be worried about quality at all. And if you want to do it, yes, you can do it, but it just gives you an extra layer of protection, that you can have extra layer of protection between a user space and a kernel space. So you can say if error propagated from here to the user space, there is another check which could monitor it in the hypervisor. And then it's already there, it's already in there, it's just adding another monitor check, which is doing it. So it just detects your access violation and it supervises it running directly on hypervisor. So you have very code to be just verified and certified. And it's using, again, not something very fancy. It's just using, again, the hardware virtualization support that you use like multiple contexts in the stage 2 of the MMU. So you have a multiple context in the MMU, and you just create a separate context for your user space and for kernel space. And then whenever there is like, so of course, for a startup, you have to set up this context, but when you are running normally, and there is an access violation, it will be detected automatically by the hardware, and it will be reported to your safety monitor. You can decide if it is wanted access or is it allowed or unallowed? So you can do it like this easily and without relying, using still the hardware virtualization score. So as I said, like there could be a solution that you can run like your QM Linux, like normal, you are running in hypervisor, you can run Android, and you can run your mixed criticality Linux, and then you could create an exception layer like where this is. And as I said, we did also like work with the Zen. And then in the Zen, you can also use a similar. They are working on this safety concept where it's a DOM zero-less. And you could run your safety monitor not directly like there is a control domain in the Zen. And you could run your safety monitor in this control domain, which is like has the safety. And then if there is anything violation goes here, and you can just has an extra protection there. But this is just a basic techniques that use hypervisor. The idea is it's not like, it could be any Linux. It's not like ready from Elektrobit. It could be from any vendor coming to Linux. I recently saw like at Safetronics, I guess the NVIDIA announced also their Safe Linux solution. And they are also doing something similar, which is quite good. It's resonating what we are promoting. They have another redundancy check in the hypervisor. So they are monitoring also so they have mechanism in the monitoring mechanism in Linux. That's fine. But they have another one, redundant one in the hypervisor. So they are also doing monitoring in the redundant one in the hypervisor. So if something goes wrong and not detected in Linux, there is a safety monitor running in the hypervisor, detects it, which gives you extra protection that you have another redundant monitoring mechanism, which is just running on hypervisor, easy to, like it's a very small code-based compute and easy to certify as well. But then the question comes like, I just give two examples of the hypervisor, but like, is it like all the hypervisor can be used like with the same technology? Yeah, sure. Like
a very, very interesting comparison. NVIDIA didn't really disclose what kind of monitoring they do.
yes,
They said, hey, we do some
Redundant channel.
fault injection here and every fault needs to be detected. But what kind of, let's say, monitoring do you suggest to do in the hypervisor? Is it just the ping that it is alive or?
yeah, so there are two things, like it depends like what you want to do. So if the ping is for like you just want to check if it is scheduled enough or it is for your temp FFI that it is fulfilling this your FTTI. So checking your safety application is scheduled in this time, you could do just a ping as well. But for spatial FFI, there could be another mechanism, monitoring mechanism. You could just do like what I was saying, MMU based, where you just create another layer of multiple contexts, like context. So for user space, it's a different context in the hypervisor, and because normally in hypervisor you have VM context. That's it for complete VM. So you could create a multiple context for each VM. One could be say SIL, and one could be QM. And once you are in the SIL to QM switch, you have to do this context switch also in the hypervisor.
That's what they also suggested, but I think they did some.
Yeah, that's
more
what we
things.
are
So
also
what is
doing it.
Not only the ping, but also what is if your process ID is corrupted or if your
Yes.
memory tables are corrupted. So they also protect they have they fear from the kernel errors. So
Yes.
the kernel will corrupt your application, and this needs to be detected.
Yes.
So
Yes, and our solution also detects all these things, monitoring mechanism.
We will shortly come to an end.
Yeah. So that's why I
We
just
can
say,
continue on the coffee break and hallway track.
yes. So like the one last thing I want to say that if like I just took two examples of open source like L4 and Zen hypervisor. So all the hypervisor can do the safety monitoring mechanism. Yes and no. You need to have fulfilled some requirements that you need to have multiple contexts in the hypervisor. You could not have only one VM. Like you need to have your hypervisor has to capability to have multiple contexts at address space level, like a VM address space level. And also like, as I said, like you have to forward some system registers or also something for monitor to monitor whatever you want to monitor. It depending on your needs, but how you define it, it has to be forwarded to your safety monitor. And the other things you talk about the ping. So it should also be able, if you want it, it should all be able to access like a heartbeat mechanism or whatever you want. If any hypervisor can do this, yes, it's eligible to do this safety monitor, hosting this safety monitor. So the idea is like, it could be any hypervisor, it could be any Linux, it could be mixed. You already have a Linux solution, which is safe. You could add extra layer on top of it, and you could have like a more protection around it. So there is no like say technology wise, like you are vendor locked. So if you don't change the Linux, you cannot, in this solution, you cannot change the Linux or you cannot change the hypervisor. So with this approach, you could have any Linux, which could be already, you say, okay, it's safe. You could have like a hypervisor from anywhere and just run a monitor, which is doing this thing. And I guess, yes. Okay.
All right.
Thank
Then we'll stop the recording, go over into the break and meet again at 11 sharp in the room for the next session on